I guess we can start. So welcome to this session called the ISS position in real time on my mobile in less than 15 minutes. To quickly introduce myself, my name is Audrey. I'm Developer Relations at StreamData.io. I'm also the co-leader in France of DevOps for Kids, the coolest initiative in the world. And you can find me on Twitter with this handle. So my challenge today will be to live code a mobile application which gives us the ISS position in real time. This application has to be iOS and Android compatible, and I got less than 15 minutes to make it. So first of all, to retrieve the ISS position, I'm going to use this API, which is an open source API, really cool one, and which is refreshed every second. So to win the bet, I'm going to use two very cool solutions. On the mobile part, I'm going to use Ionic, which is a mobile hybrid framework. And on the real-time part, I'm going to use StreamData.io, which is a proxy available as a SaaS, which turns every JSON API into a stream of data. So quickly about Ionic. Ionic is based on Angular and Apache Cordova. So we're going to make this demo with the first version of Ionic, which is based on AngularJS, but a second version has been released a few weeks ago, which is based obviously on Angular. But the logics remain the same, so it's not a problem. So what does it look like to have an Ionic application? So an Ionic application, as it's a mobile hybrid application, it relies on a web view, which is basically a browser embedded in a native application, which means that you will have separated builds for each platform you're going to deploy your application on. So as it's a web view, so browser, we are going to use languages we are very familiar with on the interfaces side. So we're going to use HTML, CSS, JavaScript. If you want to make some Sass or less, you can do it. It's not a problem. It's already integrated. And then we're going to rely on some Ionic components. So Ionic provides us some services and components which are ready to use, like, for example, a loader component, which has all the logic and all the presentation already included. So you just have to import it and declare methods on the right place in your code to open the loader and close it later. And it works. And you can easily customize it if you want it to look more like the rest of your app. On the business logic side, we're going to rely on AngularJS. So for example, for the router, we're going to use Angular router. And then we will use Cordova for two very important tasks. The first one is that each time we would like to access some devices API, so for example, if you would like to use the camera or the Wi-Fi, it's going to be through Cordova APIs. And the second big task for Cordova is to compile the application to destination, platform destination. So it's Cordova who is going to compile our application for Android and for iOS. So now looking at real-time problem. Usually when we're speaking about real-time, people suggest to make polling. So polling is that. I'm making a request, waiting for the answer, making some request again, waiting for the answer, and so on and so forth. Yeah, obviously it can work. The problem is that let's imagine that the application became very popular and that each person, each attendees of the conference are going to use it and poll the API at the same time. I'm not sure the API provider will be very happy having his API polled by 700 devices at the same time. So polling is not really a scalable solution. And quickly you enter into the polling madness, because most of the time, so that will not be the case with the ISS API because it's refreshed every second. But if you transpose it to a more general use case, most of the time you are going to make a lot of useless calls. You don't really know when your API is refreshed, so probably you will retrieve the same data a lot of times. So polling is not a solution. So now let's have a look at WebSockets. I guess you probably all know about WebSockets. At least you've heard of it. So WebSockets are really cool. They are bidirectional. So it means that they allow both the server and the client to send data to each other. They support text and binaries, which is very cool when you want to make a chat application, for example. And they got their own protocol, which is a TCP-based protocol. But it's a special one. It's a protocol which basically open a session which support binary bidirectional exchanges. It means that to use it, we will have to reconfigure proxies and load balancer to deal with WebSockets properly. Obviously, in 15 minutes, that's going to be a little bit hard. So WebSocket is not a solution for us neither. So now let's look at server-sent events. I don't know if you have ever heard of server-sent events. No? OK, so if you don't, I got a session tomorrow, a tools in action, when I compare in details both technologies to really show when to use which one for what. So server-sent events are unidirectional. It means that only the server can send data through to the client. And the second thing is that server-sent events only support text. So basically, it just completely fills the needs we got for this application, as we are just going to send text data from the server to the client. And last but not least, it's only completely based on HTML, which means that we don't have to modify anything on our API to make it work. Great. So yeah, that's the reason why we built StreamData.io, which is a proxy available as a SaaS. So basically, you will open a streaming session with the proxy, and the proxy will make the polling for you. So it's completely transparent for an API provider, but it makes a big change, because it's not every device is polling the API. It's just the proxy, which is going to poll the API and then send the data to every device through server-sent events. So that makes a big change. We added the dynamic cache. So it means that if you have your application becomes very popular and you have new customers joining the session, they don't have to wait until the next poll to retrieve data. They can simply retrieve them from the last one. And probably the most important, we have reduce the amount of data exchange by adding incremental updates. So basically, it means that if we're looking at this schema, let's imagine that on the first call, we retrieve a big document, okay, with thousands of fields. And on the second poll, nothing has changed. Well, we're not going to send anything to you. There is no point to send you the whole document again, so we are just sending nothing. And let's imagine that on the third poll, only 2 or 3 of those fields have changed. Instead of sending the whole document again, we are going to send you only what has changed, thanks to JSON patch. So JSON patch describes a set of operations that can be applied on a JSON document. So you get, for example, remove, replace, add, etc. So if we imagine that this is the document we retrieved on the first poll, and that on the third poll, only 2 fields have changed, we will receive this instead, which precisely describes what has changed in our document. And from this point, we can use a JSON patch library to apply it to our initial JSON document. So let's move to the demo and see how it looks like in real. So first of all, I'm going to create my Ionic application. So I'm going to tell Ionic start ESS maps. So the start keyword is here to say create a new project called ESS. And maps tell him to use the maps template, because the very cool thing with Ionic is that it comes with a few templates to help you when you start. So you have, for example, one with a tab menu, with a side header, or that kind of things. So here it's a maps template, a very simple one, which is going to display a map, as you can guess. OK, so it's installing out all its dependencies. Hope it will not be too long. It's initializing the Cordova project. So as we talked before, we are based on a Cordova application. It has added also an iOS application, because I'm on OS X. So the problem is, if you're not working on OS X, you will not be able to add an iOS application to your project. But you can do it with remote tools they get. So it's really nice. So let's dive into the application and run it directly to see what it looks like. So here I'm running it in lab mode. The really cool thing with the lab mode is that it gives us an overview of what our application looks like in both iOS and Android. So it's really nice for debugging CSS, not very for the rest, because it's a kind of emulator. So keep in mind that you can't emulate everything. You can't emulate, for example, the location, I think, or something like that. Well, some devices API could not be emulated. OK, so here we got our application, which is centered on Ionic headquarters. Let's go to see the code. So The first thing, my application is there. I'm going to declare, to copy-paste my Bower JSON there. To install dependencies I need, so I got one dependency to the streamdata.io.js library, which is a JavaScript SDK with a polyfill that you can use in every web or front-end or mobile application. And another one to the JSON patch library. So I'm going to install it in background. And so our application looks like this. So if you are familiar, well, that's really readable. You got a hooks folder, which is common to all code of application. It's where you're going to put all your pre and post compilation tasks. You got a plugin folder where all your plugins will be installed. So here, for example, it comes with a few plugins from Ionic, like console or splash screen. Splash screen is the screen that you can see when the application is loading. You can easily customize yours. It's very nice. Resources, where you're going to put all your icons and images stuff. But the one that is going to interest us today is the 3W folder, which has several directories, so CSS, image, JS, and lib. So every library I installed with Bower are going to be put in the lib folder, and we are going to have to look at the index.html page, which I'm going to increase. And so as you can see there, if you have made some Angular, you should be familiar with this code. We got an ng app and an ng controller, and we got here a map component. And actually, this map component is a simple directive. So, yeah. So it just basically declares a map options object and a map object, which are objects from the Google Map JavaScript API. We're going to first replace them and to make the map looks a little bit more relevant to our use case. So first we're going to declare a new position, which is Cape Canaveral coordinates. And then we're going to redeclare our map options and tell the map to be in satellite mode and deactivate Street View Control, which will not be very useful. And here it is. Looks like this. OK, so now that we got this, we would like to add a marker to follow the ISS on our map. So it's another marker object from the Google Maps API. It just takes the position and the map as parameters, and an image. So I'm going to put the image just here. OK, and if we are coming back to our application, great. So now, as you can see, we got an onCreate method there, which is taking the map as parameters. This onCreate method is used to pass the map to the controller, which we're seeing there. So obviously, the controller will need to know the ISS marker to make it move. So we're going to declare it now. OK. To put it in the index.html. And to pass it to this method there. OK, so that's for the presentation part. Now we're going to see how we are making real time in our application. So here I'm connected on the developer portal where I can create a new application. Let's call it ISS. Once my application has been created, a token has been generated to be sure that only authorized devices are allowed to see the data. And so I'm going to take my API here and to put it there to test it. So we're going to see by copy-paste this command into a terminal how it looks like the streaming session with this API. So let's paste it there. So my streaming session is opened. I received the first event called data, so that's my initial snapshot of document. And then I received patch in the JSON patch format, as we've seen previously. And the really cool thing here is that once I get that, I can go back to the My API section. And so here my API has been automatically provisionized by my curl command. But obviously, you can just manually call them and or by API too. I'm going to change my polling frequency, update it to 1. If I was having HTTP headers or query parameters, I can put them there. And if I'm coming back to my streaming session, I can see that the polling frequency has been automatically updated without closing and reopening the stream. Great. So now let's go back to our application. So we're going to first import our two libraries that we've previously installed. So the stream data library and the JSON patch one. And then in the controller, we are going to create an event source. So first of all, we are going to declare a token and the API we would like to stream. And yeah, I should have that. OK, and that's my API. OK, then I'm going to create an event source object by calling stream data create event source with the API as parameters and then the token. And once I get this object, I can register to several callbacks. The two who are really interesting to register to are first onData, which is a function that is going to send us the snapshot, the initial snapshot. So then we can say scope.iss position equal snapshot. Then we can register to the onPatch callback to receive patches. And here we are going to use our JSON patch library. So we are going to say JSON patch.apply. First, we pass the original JSON document as parameters, and then we pass the patch. Once we get this, we need, obviously, a method to refresh the map, which we are going to call there and there. And once this is done, to restart the streaming session, we're going to say event source.open. And let's go back to our application and see what it looks like. OK, so it has not found stream data.io. So let's see. OK, I guess I was not in the correct directory. In the correct directory, sorry, to install my dependencies. So it should be fine now. And I cross our finger, and it's above the sea, I fear. That's the problem with us. You know, there is a lot of sea. So most of the time, it's above the sea. We should see it moving. Come on. Yeah. So it's moving, but very slow. Here it is. So thank you very much. All resources are online. You got GitHub with all the code and a blog post to explain every step if you want to try it by yourself. And we got a booth, so you can come and visit us. We got postcards and stickers and nerfs, and we should buy some candies soon too. So feel free to come and say hello. And if you have any questions, we'll be happy to answer. Thank you.